So first of all, what is chemical reaction and chemical equation? Chemical reaction is a process in which one or more substances are converted into one or more different substances. Basically, if the composition of a substance or a compound changes, a chemical change happened, as opposed to physical change into which only the state changes. For example, the combustion of butane produces steam and carbon dioxide. Since the composition changes, it is a chemical change. On the other hand, when ice melts and turns into water, only the state changes, therefore it is a physical change. And to put this into details, chemical equations are used. Chemical equations are used to calculate the proportion of the substances involved in the chemical reaction. It is a representation of what happens in a chemical reaction. So today we are going to cover 5 main types of chemical reaction, and the first one is
combination. Combination may also be called synthesis reaction. So combination reactions usually look like this. As shown, in combination reactions, 2 or more reactants form one product. For example, sodium and chlorine combine to form table salt. Another example is burning of hydrogen gas in air to yield water. There are 4 most common types of combinations. First is metal plus non-metal to form an ionic compound. Second is non-metal plus oxygen to form an non-metal oxide. Third is metal oxide plus water to produce metal hydroxide. And lastly, non-metal oxide plus water to produce oxyacid. The next type of chemical reaction is
decomposition. Decomposition reaction usually looks like this. So as you might notice, decomposition reactions are really the opposite of combination reactions. In decomposition reaction, a single compound breaks into 2 or more simpler substances, the elements and compounds. A common example is the decomposition of water into hydrogen and oxygen gas. Another example is the carbonic acid, an ingredient in soft drinks. A decomposition reaction takes place when carbonic acid breaks down to produce water and carbon dioxide. This occurs when you open a can of soft drinks and some of the carbon dioxide fizzles out. The 3 most common types of decomposition reactions are: first, hydrates decompose to anhydrous salt plus water. Second, chlorates decompose to chloride plus oxygen. And lastly, third, carbonates decompose to oxide plus carbon dioxide. All of these 3 decomposition reactions require heat. So the next type of chemical reaction is
single displacement. The general form of single displacement reaction is here, the cation replaced by another cation that is more reactive. This chemical reaction takes reactivity of the elements into account. In single displacement reaction, a more active element displaces or kicks out the another less active elements from a compound. It is characterized by one cation or anion trading places with another to form a new product. For example, if you put a piece of zinc metal into a copper 2 sulfate solution, the zinc displaces the copper, since zinc is more reactive than a copper. The reaction between a zinc metal and hydrochloric acid to produce a zinc chloride and hydrogen gas is an example of a single displacement reaction. Another example is the displacement of iron from an iron 2 oxide solution using coke as a carbon source. The next type of chemical reaction is
double displacement. Here you can see the general form of a double displacement reaction. Here, we can see that the elements rearrange in a way that cations are paired with the others anion. A double displacement reaction, also known as a double replacement reaction or metathesis, is a type of chemical reaction where 2 compounds react and the positive anions or cation and the negative ions or anion of 2 reactants switch places, forming 2 new compounds or products. It is very important to remember to check if the displacement of the cations and anions are correct or if all compounds involved are pairs of cation and anions. For our first example, we'll look at the reaction between lithium sulfate and barium chloride. Sulfate is a polyatomic ion, so we will treat this as one anion. This ion, sulfate, does not have a subscript, or 4 is not the subscript because this is included in the ion. The subscript of sulfate is 1. Let's first determine the ions and their charges. Now, we can switch the ions and come up with the double displacement reaction. For our next example, let's look at the reaction between sodium hydroxide and carbon bromide. For this reaction, hydroxide is a polyatomic ion and is treated as one whole anion. The individual ions and the charges for these two reactants are as shown. Now, we can switch the ions as you can see here. There are two types of double displacement reaction. The first is the precipitation reaction. A precipitation reaction refers to the formation of an insoluble salt when two solutions containing soluble salts are combined. The insoluble salt that falls out of solution is known as the precipitate, hence the reaction's name. An example is sodium carbonate plus calcium chloride will produce sodium chloride plus calcium carbonate with sodium and chlorine as soluble and sodium chloride as insoluble salts. Another double displacement reaction is the neutralization reaction. The neutralization on its name is not actually based on the charge but on acidity. This reaction always yields salt plus water. The three reactions under neutralization are acids plus base will result to salt plus water. Next is metal oxide plus acid will produce salt plus water. Non-metal oxide plus base will produce salt plus water. The next type of chemical reaction is
Combustion. Technically, combustion involves a reaction between a combustible material and an oxidizer to produce an oxidized product. But commonly, combustion reaction is the reaction of hydrocarbons and oxygen to produce carbon dioxide and water. It also gives off heat in the process. An example is the combustion of methane in air to produce steam and carbon dioxide. But as you can see, most, if not all, of the equations don't have proportionate products and reactants. For example, when hydrogen gas burns in air to produce water, there is excess hydrogen in the reactant side. Another one is when methane combusts. There is excess hydrogen and carbon in the reactant and oxygen in the product side. In order to make sense of this, we must
balance chemical equations. The chemical equation needs to be balanced so that it follows the law of conservation of mass. A balanced chemical equation occurs when the number of atoms in each element in the reactant side is equal to that of the product side. Balancing chemical equation is a process of a systematized trial and error. Here's an example.
Let's say we have a problem asking you to balance the equation of the reaction between iron oxide and carbon to produce iron and carbon dioxide. In order to balance the chemical equation, we must follow these steps.
So first step is, write the correct chemical equation even if it's not balanced. This is important because of the law of definite proportions. So the correct chemical equation is Fe2O3 plus C will yield Fe plus CO2. So the second step is, write the number of atoms per element. So in the reactant side, iron has 2, oxygen has 3, and carbon has 1. And on the product side, iron has 1, carbon has 1, and oxygen has 2. So the third step is, balance the metals. So in the reactant side, iron has 2, and on the product side, iron has 1. So we must multiply the iron on the product side by 2 to get 2 iron atoms on both sides. So the next step is, balance the nonmetals except hydrogen and oxygen. So in this case, carbon is already balanced and we can already proceed to the next step. So the last step is balance the hydrogen and the oxygen. So in this case, hydrogen is absent, so we must balance oxygen. As you can see, oxygen has 3 atoms on the reactant side and 2 atoms on the product side. So we must multiply the oxygen on the reactant side by 2 and multiply the oxygen on the product side by 3 to get 6 atoms of oxygen each. Since we multiplied 2 to the oxygen in the reactant side, iron is now unbalanced. We must also multiply 2 to the iron in the product side. And since we multiplied 3 to the oxygen in the product side, there are now 3 carbon atoms, and we must also multiply 3 to the carbon atom in the reactant side. And there you have it. You have now the equation balanced.
So some important notes are, save hydrogen and oxygen for last, as they are often on both sides. Always express in simplest terms. You can only change the coefficients. Never change subscripts. When you balance an element and another element that has been balanced is unbalanced, balance that element again.